Hi. Here we have to find out how many pairs of AB of positive integers are there such that A is less than equal to B and the product is 4 to the power 2017. Now 4 is 2 square, so the right hand side we have here is 2 square to the power 2017, which is 2 to the power 2 into 2017 is 4034. So we have A into B is 2 की power something, and since A and B are both integers, both of them will be of the form of some power of 2. That's the only possibility. It can be 0, 1, 2, power can be 0, 1, 2, 3, anything, but both will be of some power of 2. So we have 2 to the power x into 2 to the power y is equal to 2 to the power 4034. Hence we have 2 to the power, here the powers will get added because base is same. So 2 to the power x plus y is equal to 2 to the power 4034. So x plus y is equal to 4034. This is the first thing. Also we know that A is less than equal to B. So if 2 to the power x is less than equal to B, it also means that x should be less than equal to y. Only if x is less than equal to y, since A and B are integers, x and y will have to be integers, right? And x, since A is less than B, x will also be less than or equal to y. Fine. So if x plus y is 4034 and x is less than or equal to y, what are the possible values that x can take? Now let's see, x, y. Can x be negative? If x is, let's say, minus 1, we'll have 2 to the power minus 1, 1 upon 2. 1 upon 2 is 0.5. A will come out to be 0.5, which is not a integer. So x cannot be negative. So the least value x can take is 0. If x is 0, y will be 4034. Next integral value that x can take is 1. So if x is 1, y will be 4033. And this will go on till x becomes equal to y. So if x is equal to y, both of them will be 2017. Right? So x can take all values from 0 to 2017. So the total number of values x can take is from 0 to 2017, which is 2018 values. So there are 2018 pairs of x and y, hence there are 2018 pairs of A and B. So the answer to this question is option D, 2018. Now some of you might be wondering, is it necessary that x and y have to be integers? Well, if A and B are integers, and since the prime number here is 2, if it were probably some other prime number, then x or y was not necessarily to be an integer. For example, 3 to the power x. Now 3 to the power x, if let's say A were 3 to the power x, now for A to be an integer, it's not necessary for x to be a integer. For some value of x, 3 to the power x can be equal to 2, right? For some value of x, 3 to the power x can be equal to 2. Some negative value of some positive value, but it will not be an integral value. So if you have 5 to the power x, for some value of x, 5 to the power x can be either 2 or 3 or 4. But if you consider 2 to the power x, if x is 1, the value is 2, and if x is 0, the value is 1. So there is no fractional value of x for which this will come out to be an integer. There is no fractional value of x for which this comes out to be an integer. Hence x has to be an integer. X has to take integral values only. Hence we will be considering only integral values here. So the correct answer is option D, 2018. Thank you.